Hello and welcome. My name is Anna. I'm an Analytics Solutions Architect Manager based in Melbourne, Australia. I work with customers around the world, helping them to harness the power of data. Like many of you watching this session today, I've been working in analytics for many years. For me, it's been almost 16. Over this time, I've seen the evolution of data platforms, from traditional data warehouses to data lakes and everything in between. The technology advancements, particularly over the past decade, have been incredible. But the one thing I find most exciting is seeing how analytics in 2022 is being used to transform businesses and industries. In this session, I'll be taking you through the AWS Analytics platform and show you how you can modernize, unify, and innovate with data. We'll go through an end-to-end customer journey using a fictitious company. At the end, we'll also get to go on the tools and build out a use case together. As a data professional, whether you're a data analyst or a data engineer or even an information consumer, you are key to unlocking the power of data. And today, I'm going to show you how. We've got a lot to cover, so let's get started. Analytics has been a driving force behind industry disruptors such as Uber, Airbnb, and Netflix. But analytics is not just a priority for digital natives. Analytics heavily influences organizational performance across all industries and segments. At AWS, we know that for our customers, harnessing data, while yes, it can be challenging, is imperative to staying relevant now and in the future. So why is this the case, and how are organizations getting value out of what is essentially ones and zeros? Well, in a nutshell, organizations are using analytics to drive two main outcomes. The first is to reduce the cost of operations, that's impacting the bottom line, and the second is increasing revenue, that's impacting the top line. Let me tell you a little bit more about the value our customers are driving in more detail. Analytics can help organizations make decisions faster. Georgia-Pacific, a paper manufacturing company, uses AWS Analytic Services to predict how fast their paper production lines should run. They use data points in these predictions, such as the quality of the paper roll, so that they can optimize the speed of production and avoid paper tearing. This leads to huge efficiencies in the production line and potential cost savings in the millions. Global pandemics are hard to predict. When COVID happened, AWS customer Via Medical used AWS Analytics to respond to the unexpected. They used insights to help the supply chain team create a production plan to scale ventilator production by 20 by. They also reduced failures during quality testing by 60% thanks to machine learning, which can predict unit failures. Formula One leverages AWS machine learning to improve the racing experience for fans. The sport is not only a battle between the world's best drivers, it's also a battle between some of the world's most innovative engineers. During a race, 300 sensors generate 1.1 million telemetry data points per second, which is combined with 70 years of historical race data. Using AWS, F1 can predict race strategy outcomes with increasing accuracy for teams, cars, and drivers, as well as fans. Next time you're watching the F1, check out the real-time fan statistics on screen. It really does add to the customer experience. All customers are eager to improve efficiencies and outcomes. Using AWS Analytics, Domino's Australia were able to reduce pizza delivery times. Now, it's impossible to reduce the time it takes to cook a pizza, but Domino's were able to use machine learning to predict the likelihood of a customer progressing to the checkout. That's right, by putting their data to work, they can start making the pizzas even before the customer completes their order. There are many more AWS customer stories that showcase outcomes and values using data. But let's dig into how these success stories are possible. A common theme across our most successful customers is a modern data strategy. Now, a modern data strategy allows you to handle enormous growth in data and address various new use cases, not just for now, but also in the future. And one that can tie together the full data journey right from storing your data to putting your data into action. Let's double click on what a modern data strategy looks like on AWS. At the core sits a data lake based on Amazon S3, which can store any type of data, structured, semi-structured, things like audio files and videos, at almost limitless scale. Amazon S3 provides highly durable, secure, fault-tolerant data storage that allows you to store your data in open data formats for analytics. Around that core, you have AWS Lake Formation, which provides centralized security and governance on top of your data. What we find is that customers who have a good data governance strategy can move faster and on average will implement higher value use cases. AWS Glue automatically discovers schemas, catalogs your data, and keeps your data in sync across all your data stores. From here, customers are empowered to use the processing engine which best suits their workload using a range of purpose-built services, some of which you can see around the perimeter of this diagram. With the foundation of the data lake, you are able to store your data once and use it many different times and in many different ways. And that is the core to the data platform philosophy at AWS. So how do you build a modern data strategy? Well, a modern data strategy is comprised of 3 strategic pillars: Modernize, Unify, and Innovate. It can be easy to think of these pillars as a linear progression. So for example, first I need to modernize and get out of my data center, move all my applications to the cloud, and then I'll start analytics. Or that machine learning is something that can only be done in phase 3. These pillars can be activated at any time and in any order, whether you're getting out of your data center or choosing to start with your first use case. Now let's take a look at each of these pillars in more detail, starting with Modernize. Many organizations are still running legacy data infrastructure on premises or self-managed in the cloud. These environments are tedious, they're time-consuming, and expensive to run. Late last year, I was presenting to a customer who was looking to modernize their on-premises data warehouse. I told them about all the wonderful and powerful features of a data platform, infused ML, structured and unstructured data processing, things I thought could revolutionize what they were doing with data. Of all the enhancements and capabilities, the team I was talking to was most excited about the built-in business continuity features. They had spent considerable time and effort in building and maintaining a high availability and disaster recovery solution for their legacy platform. The thought that this would come out of the box with a recovery point objective of 0 was something they were really excited about. And of course, this is only the start for this customer. They will reap the benefits of running in the cloud for years to come. They will no longer be limited to monolithic architectures, so it gives them the opportunity to look at their workloads individually, break them up into functions, and only pay for what they use. They'll be able to innovate and experiment within an afternoon rather than taking months or weeks to set up a POC or MVP. The bottom line is, for customers running on-premises workloads, there is a better way. AWS Database Services can take care of all management tasks such as server provisioning, patching, configuration, and backups. We have many sayings at AWS, but one of my favorites is using the right tool for the right job. In 2022, workloads are rarely homogeneous, so AWS offers customers a variety of database options to suit different workloads. From relational databases like Amazon Aurora and Amazon RDS, all the way through to non-relational DBs, including Amazon DynamoDB for single-digit millisecond performance at any scale, and Amazon Neptune, a fully managed graph database. There are many, many more options as well. And for analytics, our services provide an easy migration path for customers who are running data platforms on premises and self-managed in the cloud. By migrating to an AWS managed service, customers can refocus their efforts on what is most important to the business. To help customers migrate, we provide purpose-built migration services such as AWS Database Migration Service and Schema Conversion Tool. This helps automate and accelerate the time involved in migrations. And we also provide professional services and partners who can help you modernize faster. Now let's talk about our second pillar, Unify. By unifying data in a single data lake, you can reduce data silos. Core to this unification method is democratizing access to data, where, yes, we still have governance, access controls and security, but we're also empowering every stakeholder in an organization as well as third-party partners to be able to get access to the right data at the right time. Now, when I talk to customers about putting their data to work and the use cases they want to drive into the future, they are really diverse. And for this, you would likely need a range of purpose-built data stores and services. Let me introduce you to the key analytic services in the AWS data portfolio. Starting with Amazon Athena. Athena is an interactive query service which allows you to run SQL queries directly on your data sitting in S3. It is serverless, so there's no infrastructure to manage, and you only pay for the queries that you actually run. Amazon EMR takes the heavy lifting out of running and managing big data platforms. It allows you to process petabyte-scale data using the latest open-source big data frameworks, such as Spark, Hive, Presto, HBase, Flink, and Hootie. Like Athena, EMR runs directly against the data stored in your S3 data lake. With new serverless options, it's never been easier to run open source frameworks. Think about how many times you use search today. I guarantee you've used it more than once and probably more than 10 times today. Perhaps you searched on a web browser or a website or an app. Search is key in our daily lives in 2022, but doing a full text search using traditional databases can be really slow, and querying for a non-exact match with ambiguity or spelling mistakes or adding additional context to the search can make these queries even slower. Amazon OpenSearch Service is a powerful analytics and full text search engine. It opens up the doors to some advanced analytic use cases such as interactive log analytics and real-time monitoring, which you can apply to pretty much anything from IoT devices to real-time application logs. It can also facilitate things like website search, where you want to use OpenSearch to add customer context to your search results. Search can be a really powerful addition to your analytics capability. If you want to do real-time processing of streaming data, you can use Amazon Kinesis. Amazon Kinesis makes it easy to collect, process, and analyze real-time streaming data so you can get timely insights and react quickly to new information. We also have an option for customers building real-time streaming on Apache Kafka. With Amazon Managed Streaming for Apache Kafka, you might already know this as MSK. So you can choose the tool which best fits your organizational capabilities. With Amazon Redshift, you can take a modern data approach to analytics by adopting a data lake-based architecture. You can take advantage of real-time analytics and AI/ML use cases without re-architecting because Redshift is fully integrated with your data lake, as well as other purpose-built services such as transactional databases, streaming services, and machine learning services. I've spent most of my career using data warehouses, and for me, Redshift is redefining what a data warehouse is in 2022. AWS Glue is a serverless ETL tool which provides seamless movement of data across services and data layers. Glue provides development options, so depending on your skill set, whether you're a data engineer or a data analyst who prefers a low-code, no-code experience, there is a design time environment to suit you. And finally, Amazon Quicksite is a BI visualization service which allows you to automatically scale, embed dashboards into apps and websites, and takes advantage of inbuilt ML functions. With Quicksite, you can get started quickly with no service to manage. You can scale from 1 to thousands of users and only pay for what you use. At Reinvent 2021, we launched 4 new serverless and on-demand options for analytics. With this, AWS now has the most serverless offerings for data analytics in the cloud to make it easier for you to do what you do best, and that is creating value and not managing infrastructure. That brings me to the final pillar, innovate. This is where we can really put our data to work with a modern data strategy. Many of the use cases I mentioned earlier are powered by machine learning, which is one of the most disruptive technologies of our generation. Machine learning has traditionally been seen as a domain of experts with PhDs and mathematics degrees. AWS brings ML to the masses by providing tools which can help customers integrate machine learning throughout their entire organization with minimal upskill required. We do this by bringing machine learning closer to the data and removing the skills barrier to entry. As part of the portfolio, AWS Services provide ready-made intelligence for applications and workflows, often addressing a business problem end-to-end. These services address common use cases such as personalization recommendations, contact center intelligence, document processing, intelligence search, and many, many more. Amazon Sagemaker is our fully managed machine learning platform for building, training, and deploying models. It is the most comprehensive ML service with tools for every step of the deployment, including labeling, data preparation, feature engineering, statistical bias detection, auto ML. In addition, AWS Database and Analytic Services have built-in ML and seamless integration with Sagemaker. With Aurora ML, Neptune ML, Redshift ML, and Athena ML, you can train and run ML models directly within the database or service of your choice. Quicksite has also been infused with ML to provide automated forecasting and anomaly detection, which you can apply in a few clicks. And Quicksite Q allows questions to be asked of data using natural language expressions. With AWS, we provide options for customers to innovate with data at any maturity level. Now, I'd like to take you on a journey using a fictitious customer example to show you how you can use the core elements of a modern data strategy to drive value. I'm going to call my fictitious company Ride With Us. Ride With Us are a bike share service. They are streaming data captured from their bikes using Amazon Kinesis, with events like speed, stops, starts, location, and the orientation of the bike. They also have information about their customers. All this data is coming into the platform and landing in near real time in a data lake, Amazon S3. Now from here, this data can be used for different use cases and by different personas. I'm going to walk you through 4 use cases today to demonstrate how Ride With Us can put their data to work. The first case we are going to implement is capturing metrics about our bikes, trips, and members. The most popular location, average trip duration, month-by-month revenue by state. These types of queries are best done using a data warehouse platform like Amazon Redshift, which is seamlessly integrated with the data lake. This is where we can combine operational data coming from our bikes with information we might have stored in a CRM or ERP system. Having these insights enables our business to make better decisions faster. Decisions such as where should we invest in our next new bike depot, or who should we target for our next ad campaign. In the second use case, we are going to merge our bike usage data with weather data and use ML to predict how many bikes are going to be required at a bike station on a particular day. This will help manage the number of bikes at each location, ensuring there are not too few nor too many, and by doing this, we can reduce the cost of operations. For this use case, we need to use the power of machine learning, but as a new organization, we might not have access to data science skills. This is where Redshift Ml comes into play. Using the power of a modern data architecture, Redshift integrates seamlessly with Amazon SageMaker so that you can train and run inference on your machine learning models using the tool and language of your choice. In this case, it's SQL. If you are interested in this use case, stay tuned as this will be the basis of our demo later in the session. In the next use case, we are going to provide riding statistics to our hundreds and thousands of users through our mobile application. For this, we would like to use a service like DynamoDB, a NoSQL database optimized for low latency reads at scale, and will be able to service potentially millions of users in the future. We can not only provide rider statistics, we can also provide riding benchmarks and even create games and challenges. This sort of use case can be used to improve customer experience and uncover new opportunities for our business. In the last use case example, we are going to implement trip profiling for our bikes. Accidents, damages, and bike breakdowns cost the company money and in some cases results in customer churn. Through Amazon Open Search Service, each trip can be monitored in real time. Instead of having to program alert thresholds, we can let the inbuilt anomaly detection inside of OpenSearch identify proactively an accident, damage, or when a bike might be showing a problem. In this case, we can proactively contact our riders and respond better to the unexpected. So you see how we can evolve our use cases over time, using the right tool for the right job and activating the different services as they are required. Now comes the fun part. Let's see one of these use cases in action. For this demo, we are going to be focusing on use case number 2, predicting the number of bikes required at each station for any given day. Remember, at this point, our organization may not have access to a data scientist, so we are going to leverage low and no-code capabilities to build this use case end-to-end. We're going to be cleansing our dataset using Glue Data Brew. Amazon Redshift allows us to query the data and combine with other datasets like weather. It also allows us to seamlessly integrate with Amazon Sagemaker to run our machine learning model. Finally, we can visualize the data to find patterns and insights in Amazon Quicksite. So let's go. This demo looks through the eyes of the analytics team at Ride With Us, who are analyzing bike trip and weather data. For this demo, I'm going to use the public City Bike New York dataset. With the City Bike system, you can pick up and drop off bikes at designated stations around the city. Now, for a bike system to be successful, bikes must be available when and where members want to use them, which means that bikes may need to be moved manually between stations during the day. No bikes at a station leads to poor customer experience. Too many bikes will impact the bottom line. We are going to use bike trip information and weather data to predict how many bikes will be required at each station on a given day. But first, let's take a look at the dashboard, which really tells an interesting story about the year gone by. Some noteworthy observations. You can see here the history of the bike trips over time. There is an unseasonable drop in usage from March until May in 2020, likely due to stay-at-home measures issued in New York at this time. We also see in December that ride usage is dropping significantly. Using this box plot, we see that weather has a significant impact on the number of trips for a given day, with snow and wind having the highest impact. We can also see at the top here a forecast and prediction. Tomorrow is going to be snowing and a cool -2.3 degrees Celsius, and the predicted bike usage will also be down again. This dashboard is also able to help us find patterns in the data which is not shown on screen. Let's see how this works. Show me the temperature by day for December 2020. You can see here a large drop in temperature which could be causing the bike rides to decrease. This dashboard has been built using Amazon's BI visualization tool, Amazon Quicksite, and a feature called Q allows us to index data so that we can ask questions using common language expressions. So in the next 5 minutes, I'm going to show you how you can build the key elements of this dashboard from scratch. The City Bike data is in CSV format and contains operational information about how City Bike customers are using bikes. You can see here we have the last 2 years of data stored in an S3 bucket. Unfortunately, data is rarely ingested in a format which is immediately usable. Generally, it requires some transformation or cleansing. Before we can use this data, we need to prepare it. We're going to make 2 changes. We're going to harmonize the date field, and we're also going to change the date of birth column to age so that we can use this feature in our dashboards. For this task, we can use a no-code tool called Glue Data Brew. Here we are in the Glue Data Brew console. The first thing you do is create a project. You give the project a name, choose your dataset. In this case, we'll pick the S3 file location which holds our data, choose your role, and away you go. Glue Data Brew just takes a moment to launch, so I'm going to speed up the video here. Once Glue Data Brew is launched, you can create the cleansing rules. The first step is the harmonization of the date field, where you can use out-of-the-box features to manipulate the date within just a few clicks. The second thing we're going to do is calculate age from date of birth. For this, we'll use the dateDiff function and subtract date of birth from today. Aggregate by year and apply. Now we can run the job, which will transform your data and store it in a location of your choice. You can select the name of the job and the output. If you're storing your curated data in a data lake, then you might want to select S3. But in this case, we're going to select Redshift as the output and load it directly into a table. Choose a role and execute the job. We can check on the status of the job by going into the monitoring screen. Now I'll just speed up the video again while the job runs. The job has now successfully executed and the output is in a Redshift table. We're going to take a copy of the table name in the clipboard so that we can query it in Redshift. Once in Redshift, we can see that our city bike data is available. If you remember back to our dashboard, we saw a strong correlation between weather data and trip data. I'm going to do a quick select on both tables so that you can see the attributes that we have available. Now we can combine this data using standard SQL. This can tell us things like the most popular start stations, as well as the number of trips for the coldest day of the year. One of the things we want to do is start predicting the number of trips for each station by day, so that we can anticipate demand and ensure bikes are available at the right stations at the right time. Thanks to the new Redshift Ml feature, we can create and train a model directly inside of Redshift without the need to launch another service or do any complex processing like turning string values into numbers. We're going to use the linear regression model to predict the number of trips based on attributes such as precipitation, temperature, day of the week, and, of course, the all-important start station information. To do this, we can use the create model syntax to train a model. Once we start training our model, we can see the status by running the show model command. At this point, Redshift has already started integrating with Amazon Sagemaker and running the data against different hyperparameters using a feature called Autopilot. Let's have a look at what is happening behind the scenes. As you can see, the job is currently running in Amazon Sagemaker. We can see the different training models being run and the accuracy score for each of the jobs. At the end of the training process, the function will select the algorithm and parameters with the lowest score. We will wait just a moment for the training process to complete. Now, let's go back to Redshift and check the status of our model. You can start using the new trip prediction model in your Redshift queries by using the function. As you can see, we can predict the number of trips for the 18th of December 2020 based on the weather forecast and other attributes like the time of year and the start station. We can use this to anticipate the demand at each bike station. We can also use this data to create impactful visualizations and dashboards like the one I showed you earlier in Quicksite. And just like that, we implemented a use case in under 10 minutes and uncovered some pretty cool insights. In today's session, we covered the key components of a Mon data strategy and the 3 pillars to help you get there. Modernize using purpose-built data stores fully managed by AWS. Move faster by unifying your data through a well-governed data lake and purpose-built data stores. This will reduce your time to insight for all your analytics use cases and protect one of your most precious assets into the future, your data. And the final pillar is innovate, using the power of AI/ML with a tool set to suit your skill and use case. Remember, you can start from any point, and I challenge you to think about how you can put your data to work using these 3 pillars and the AWS data platform. If you would like to learn more, I encourage you to get engaged with our training and certification content. AWS Skill Builder is our online learning center that makes it easier for anyone from beginners to experienced professionals to build AWS cloud skills. Scan the QR codes on your screen now to get started. Thank you so much for joining me today. I hope you found this session insightful. I cannot wait to see the impactful solutions you will build in the future. Please don't forget to complete the survey on your way out, and as always, happy building. Ciao.